Welcome to session 5 of the R workshop. As you may recall from last time, today the plan is to go over an extended example of processing and analyzing a real data set. I'm going to use one data set from one of my own projects as an example. I want to emphasize up front, and I'll probably emphasize this again repeatedly, that there is not just one way of doing it. This is an example of one particular way of processing and analyzing a data set, and not necessarily the most efficient way, just a way that I think is easy to illustrate as part of an introductory R workshop. And furthermore, I'll emphasize that, in my opinion, anyone who tells you that there's one right way to process and analyze a data set in R or to structure your code is selling you something or has a high opinion of themselves. This particular example that I've prepared is set up to be easy to understand in a step-by-step way. So some parts of it are going to be sort of more than necessary. That's intentional, but hopefully it will illustrate certain steps that you can take in a realistic setting. And before I start showing you code, I'm going to talk a little bit about the study so that you have some context, because I feel like having a set of clear goals for like what I need to do with the data helps me to feel like I understand what I'm trying to do with the code, and I feel more comfortable um, analyzing the data. So the data that I shared with you in the zip file are a de-identified version of a data set from a study that Rosanna Summers and I conducted in 2015. In this particular study, we're interested in whether the outcome of a lawsuit pertaining to employment discrimination on the basis of mental illness would affect people's judgments of the concept of employment discrimination on the basis of mental illness and people with depression and other mental illnesses, generally speaking. So we set participants up with a scenario that we told them was a real lawsuit that had taken place, a real court case, in which a woman named Amy had applied for an office job and was invited for an interview. And the interviewer asked her why she graduated college a little bit later than expected, and she explained that she missed a semester of college for mental health reasons. But that she now sees a therapist and takes medication to manage her depression. And then later, the company declined to hire her, citing her history of mental illness as the main reason. So this is unambiguous employment discrimination on the basis of having a history of depression, which in many cases in real life is not illegal, but participants don't necessarily know that. And so we told the participants that Amy sued the company after not getting hired for discrimination, and the judge issued a ruling. And this is where the manipulation comes in. We manipulated whether participants were told that the judge ruled in Amy's favor, saying that it was illegal to refuse to hire someone on the basis of mental illness history, or that the judge ruled in the company's favor, explaining that it's currently legal in the United States to refuse to hire someone on the basis of their mental illness history. So there's one manipulation with two conditions, the legality or illegality of this particular form of employment discrimination. And we're interested in whether there will be differences in how much the participant supports discrimination on the basis of mental illness, whether they surmise that most other people support discrimination on the basis of mental illness, their evaluation of Amy as a person, whether they like her or not, and their more general evaluation of people with depression and people with mental illnesses. And we believed that these responses to the scenario might be different depending on how much participants tend to trust the court system as a legitimate institution in general. And so there you'll see that there's a sort of key individual difference measure, or at least measure of opinions that we take as persistent individual differences for the purpose of this study. That has to do with whether people trust the courts, think that they're legitimate, and so forth. This here is the code file that I sent you. And this is more than the full list of files that I sent you, but the files that I sent you are this analysis file, which we'll get to later, the current file, the That's this one here called processing one. The data, which I've called Summers and Burke 2015.csv. I should acknowledge Rosanna is kind of the lead on this project. She is an excellent scholar in psychology and law, um, and is about to start a position as a professor of law. Um, and this extra functions.r file, which is more code that contains extra functions. To create this demo file, I started with some actual syntax that I had written in order to analyze the data from that study, but I changed it substantially to make it, I think, hopefully really easy to walk through in a workshop setting. And if you look back at the syntax later, there's a little note about that at the beginning. The first actual step that I'm going to take in reading in the data is I'm going to set a file name, which in this case is very simple. I know that the file is called Summersandburg 2015.csv, so I'm just going to store that in a variable called file name. It's just a string indicating the file name. This is a step more than you would need to take, but sometimes if the file has like a unusual path or something, it's nice to just have that path stored as a string. I'm also going to um, attach a couple of packages that will be useful. So I'm going to use the car package again. I showed you that in the main portion of the workshop, the intro portion of the workshop before. And that's because I'm going to use the recode function from that car package. And the psych package, I'm going to use this function principal a little bit later. Okay, so this is the same warning that we got in the main portion of the workshop, that there's a function called logit present in both of those packages. That's okay because I'm not planning on using that function. Otherwise, the order in which I read them in would matter. One thing that I often do towards the beginning of analyzing a new data set is I will read in a code file containing a bunch of user-defined functions that I've written that I like to have available when I'm working with data. I'm not using all of those functions in this demo, and I haven't shared all of them with you, but I have shared a bunch of them with you, and they're present in this extra functions.r file. And we can look at them a little later if you want more details about them, but for now we're just going to read it in. So this is a function I haven't shown you yet, source. All it does is execute an entire code file based on the um, path to that file. I don't have a full pair because extra functions.r is again located right in the current working directory. So now you can see that having run that file gave me access to a bunch of functions that I have written that are now in the global environment that weren't there before because this was an empty R session initially. So all of these objects, except for file name, are functions that were defined by this file. One of them you've already seen, that's minmax, which I can just print to the console because I happen to know that function is very short because I used it as an example in last week's, I think in last week's workshop. So yeah, if I type the name of the function without the parentheses at the console, it will just show me the function definition instead of executing the function, which is why I was able to do that a second ago. Just to remind you of how to create a user-defined function, I'm also going to just run this. This is a really simple user-defined function. I'm calling it tab NA, and it is it's a function. That's what this does. The function defines a function, and here the argument is just anything. ... allows you to supply any number of arguments. And then having when the tab NA function is called, it's going to execute this one line of code, which returns a table with those same arguments and one additional argument, use NA equals always. So this is just a wrapper for the table function. And having run it, we'll be able to use tab NA to tabulate something and always show how many missing values there are, even if there are 0, without having to supply the use NA argument every single time. Which is, for me, a more useful default than the default for table, which is to not show missing values at all. This is not the tabulation function I use when I'm analyzing data normally. I have another one that I guess I didn't share with you, but maybe I will someday when I make it a little more user-friendly. Okay, so then we get to the first step that actually reads in data. make a name for the data frame, which I'm calling data.raw here. And it's just the result of the read CSV function with the file name we've already defined, which remember is this, and one additional argument, which is that I don't want it to convert strings to factors, and that worked fine. By the way, this is maybe useful as an organizational tip. I like to set up when I'm analyzing a data set, I like to do it using two files, one for processing the data to make it ready to analyze statistically, which is the file I'm walking through right now. So this is not designed to conduct any statistical tests, just to get the data ready to conduct statistical tests. And the other one will actually conduct those tests. And then within those files, I like to have sections that use white space and a bunch of comment characters in order to make it really easy to see the section headings so that I can scroll through and find the place um, that I want to work with. So here we've imported the data. It was just a regular CSV file, so I didn't have to do anything all that special in reading it in. Um, Nowadays, so this data file came from Qualtrics, but it sort of the old way that Qualtrics generated CSVs, and so nowadays you would need to skip some rows and so forth because Qualtrics has a bunch of extra information in the first couple of rows. Actually, it had one extra row at the time, but I think when I de-identified it, I also eliminated that row. Oh yeah, it says that right. Well, it says some of that stuff right here. Well, I guess I'll comment on this because you'll probably see me doing this. The variable names in this data set are largely in camel case. So if we look at the names, you can see that. Not all of them, but some of them. So deper avoid here is like I tend to avoid people with depression, or Amy positive. Amy, remember, is the character who in the story who sued the company for employment discrimination. This is a positive evaluation of that character. And camel case is pretty unambiguous for most people, but when I'm actually writing code, I usually like to have my variables all lowercase because I don't like to use shift a lot. I might recreate lowercase names for some of these variables in the code below. It's actually been a couple of years since I've really thoroughly looked at this code, so I'm just remembering that I did that.